Multilayer ceramic condensers have many advantages, but in some cases their capacity may be decreased at DC voltage. The phenomenon referred to as DC bias effect or DC displacement and may constitute a problem for a construction engineer who does not know the characteristics of the condenser type. Fortunately, new developments in ceramic material technologies based on barium Titan O3 of Murata Electronics provide decrease in the effect by adaptation of buried Titan O3 crystals to decrease reverse polarization effect. It decreases DC bias effect, but in many cases it is associated with a decrease of the initial capacity. Murata Company could develop a material with minimum capacity decrease with respect to a zero displacement level, taking into account the DC bias effect at the planning stage as the simplest way to control the DC bias effect. Today the procedure is very easy due to interactive software system and engineer circuit design at the component level. The user shall only enter basic parameters and the program will automatically plot a diagram demonstrating behavior of a condenser at different current levels on the basis of measurement data. The user may also specify additional information, for example heat resistance and ambient temperature, and receive an individually adapted solution. Nowadays, construction engineer may receive data on DC bias effect by several mouse clicks and take them into account when they select a component. For example, the engineer may decide to use two condensers with 0805 case instead of condensers with 1210 case by entering the appropriate parameters into interactive design tools. It is important to note that capacity values provided by specifications exclude DC bias characteristics. For example, if a development requires 10 microfarads, the engineer may need 22 microfarads condenser to provide specified capacity. The knowledge will spare the engineer time. Engineers make a typical mistake when they select capacity exceeding the required capacity without checking DC bias effect. In this case, DC bias effect on a capacity value will be increased. For example, if we will take into account DC bias, it may happen that usage of two multilayer ceramic condensers with a lower capacity will be more reasonable than usage of one condenser with a higher capacity.